Principles of mathematics are fundamental to artificial intelligence, which is the basis for advancement and progression in the modern world, as they replicate human activities and decisions. Artificial intelligence revolves around various mathematical principles as they use certain algorithms to take input and produce output simultaneously, such that they can learn the data similarly to how humans would. This process is called machine learning and is used in the field of neural networks. The math used in neural networks can be done by hand and is relatively simple, as it involves linear and nonlinear algebra, differential calculus, probability theory, and statistics. However, machines are used to solve this math for two key reasons. Firstly, since neural networks are used to replicate the processes in the brain, the quantity of neurons would make manual mathematics impractical, as it would take too long. Furthermore, the majority of the calculations that neural networks undertake involve matrices, which rely on getting as many combinations as possible, and therefore neural networks are required to ensure efficiency. Neural networks contain various components including weight, a connection between neurons which has a value identifying the significance of a neuron, in which case the weight is directly proportional to the value. Bias, which is a form of weight and is imperative in the idea that neural networks replicate human decisions, as it is used to consider non-observable facts regarding certain situations. And the activation function, which is a function in the neural network that converts linear information into more distinct nonlinear functions, so that it becomes easier to make decisions. Usually, the activation function uses either the hyperbolic trigonometric function tan h of x, sigmoid x, or relu x equals max 0x. There are three layers in a neural network: the input layer, the hidden layer, and the output layer. The input layer is the part of the neural network where data is fed into the machine. The type of data output may vary depending on the type of machine learning that the neural network is conducting. This input data is then fed through the hidden layer by a series of matrices. The process involved in this case is typically to get the input, multiply by the assigned weight, add any biases involved, apply the activation function to the result of the preceding steps, and to take that as an output result. This is then repeated on every output result until the final layer is reached, which is the prediction. Then, the output must be subtracted from the expected output to find the margin of error. An algorithm called backpropagation is then applied to adjust the weight by differentiating the loss function with respect to the weights for a given input-output result until the desired result is reached. Currently, neural networks are used in a range of professional fields, such as electronics, manufacturing, telecommunications, banking, business analytics, education, military and defense, medical research, and transportation. In addition to this, with a gradual and inevitable improvement in neural networks, it is possible for nanobots that can preserve memory, similar to how phones save data, to be made in the future, and is also possible for safe self-driving cars to be prevalent in the modern world. In summary, neural networks are founded on the premise of fundamental mathematical concepts, meaning that change and advancement in society is directly proportional to its level of understanding about math and its applications.